In this video, we'll be discussing rational inequalities. Now, the only thing that's different from polynomial inequalities with rational inequalities is that you could also get a sign change when the denominator is 0, because that makes the expression undefined. For example, let's solve this inequality and then graph the solution set. So the first thing we have to do is we cannot, so the first thing to be warned, you cannot multiply both sides by x minus 5, because you know that multiplying by a negative flips the sign, multiplying by a positive leaves the sign alone, but here you don't know which one this is. So instead what you need to do is bring the 3 to the other side and get a common denominator and put everything together. So that would be minus 3 less than or equal to 0. Common denominator is x minus 5. Multiplying top and bottom of that by x minus 5 gives minus 3 times x minus 5. And then you have the ability to put the fraction together. Well, now that you have that, you have 2x minus 3x is going to be negative x over x minus 7, and then you have minus negative 5, so plus 5, so minus 2 all over x minus 5 is less than or equal to 0. You can factor out that negative, and if you factor out that negative and divide both sides by it, then you will flip the sign and get x minus 2 over x minus 5. And so now we have two types of key numbers. Our key numbers are either where the numerator is 0, which is x equal 2, or where the denominator is 0, which is x equal 5. So we go through this like we did before. Section off those two spots, 2 and 5. Write out both the factors here, x minus 2 and x minus 5, because we know that as far as the sign is concerned, division and multiplication are the same. And so then we're looking at x minus 2 over x minus 5 and what happens with that. All right. Again, we can pick any value we want. Here, again, though, it's worth noting that this is where the expression is 0 because the top is 0. But here is where the expression is undefined. Okay? So, we can pick a value here. 3 is a good value. 0 is always a good value when we can choose it. 6 works here. Plugging 0 in, we get a negative. Here we get negative 5, negative, negative, and negative. A negative number divided by a negative number would be a positive number. Similarly, positive, negative, so negative, positive, positive, so positive. And then we have to figure out what we were looking for here. We want this greater than or equal to 0, which means we like that interval and we like this interval and we like it equal to 0. In other words, what we have is the interval from negative infinity all the way up to 2, and we include it because we can have it equal to 0. Union. Here it's undefined, so we have to leave that open 5 out to infinity. Okay? That is, if we were to graph the solution set, we would have, if this were 5 and this were 2, we'd have it closed there but open there, shade in everything greater than 5 and everything less than or equal to 2. And now it's time for you to try a couple of examples, so go ahead and solve each of the following inequalities and then graph the solution sets. On the count of 3, I'll reveal the solutions. 1, 2, 3. So as you can see here, I go ahead, I take things on both of them, I take it to the other side, get my common denominator, put the fractions together, simplify to get down to here. Find my key numbers. Then I go ahead, break up my interval, test the signs of the factors to get the total sign. Then noting what I want and where where it's positive, negative, 0, and undefined, I go ahead and I figure out what my solution set is, and then I graph. For more practice in solving rational inequalities, be sure to see page 185 of the textbook and work problems 3 and 41 through 52. In our next video, we start talking about exponential functions.